Hey guys, this is the data platform team at Robinhood. We are working on hosting the big data computational framework to serve our internal and external customers. This is Jiawei. I'm mainly working on the Presto and Presto integration with other systems.
This is Yichuan. I'm also mainly focused on Presto ecosystem, working with Jiawei.
This is Wenlong. I'm focused on our in-house data compute job submitting library and some of the Spark ecosystem, but it helped out Jiawei and Sam with Alluxio.
Hi, this is Grace. I joined Robinhood 3 years ago, and I have been helping effort around Robinhood Data Lake and data platform systems in past 2 years. And it has been an exciting journey to see the growth of scale in our data world. And this is my friend, Bo.
As one of our efforts to improve our performance of our query system, we're exploring Alluxio as a caching solution for our Presto. So based on our current setup at Robinhood, we're using S3 as our data storage, and we're using the Presto and some part of Spark SQL for interactive query. We use Hive as our meta store to store the metadata that directs to our data in S3 for our query system and our ingestion system to use. And in front of our Presto layer, we have a user interface from different third parties. We also use Jupyter Notebook with Python and R library. So there are various endpoints for people to connect to our data queries. But internally, our majority of queries are running through Presto using the S3 data lake and the Hive metastore. So as part of our daily task, we're running a lot of ad hoc queries. People are using our system to run daily jobs to query daily data or weekly data. But as a financial institute, we're storing data for auditing for a very long range of time. So this makes a contradict that we're storing a huge amount of data, archiving them, but the majority of users are only accessing the data from the recent dates or only a limited number of data sets. The access on data sets are vastly biased. That means for some of the data sets, people may never access it or only access it 1 or 2 times a day. These are used very rarely, but for some other data sets, people might be accessing it all day long. Maybe 50% of the query can involve a single data set. That's a huge difference because if we can improve the performance on those data sets that are accessed more often, if we can improve the performance on the data part, on the partitions that are accessed more often, we're able to greatly improve our average performance on most of the queries. So for our daily traffic, we have some ad hoc queries. Those are coming from visualizations, where people are just performing very simple filters and aggregations that are generated by the UI. And the UI will apply those filters on a large range of data and aggregate them to show a beautiful visualization. As for the UI, it always comes with a limit because user cannot read infinite number of data. The result must be human readable. That means it always comes with a limit. So it normally features the most recent data, just like whenever people open the dashboard, they want to see the data from last hour, last day, at least the most up-to-date data. No one to see some very old data every day. So it's fetching data from like yesterday and concentrating on a very small number of data sets that people are using every day all the time. And specifically, it is repeated many, many times because everyone wants to see those dashboards. There are lots of people every day, the first thing they do is to open the dashboard and see the data from yesterday and do whatever they want. So those ad hoc queries should benefit the most from a caching solution, if we're able to improve the performance with the caching, they can cache the data from the most recent day or most recent week and on the most frequently used data, so that people who always access the data from the cache instead of having to read through S3 all the time. And there's another kind of job called data report generations. This is strictly limited to the most recent data because whenever they run a report, it is always for the for defined time range, like last week, last month. They're running on demand. It's not always by schedule, but it is still run with the rough schedule of daily or weekly. And this is also a very good candidate for caching solution because it is always accessing data from a defined time range. And a single report will always access the same data sets because people will not be always changing the queries that are generating those reports. So the third use case of caching is data analyzation queries. Those queries are normally coming from some scheduled jobs, data jobs, and data services that are serving end users, some data products. So those are very comprehensive queries that can contain a lot of different aggregations, stages, and filters. Because those are normally generated automatically by some user-defined services, which means they're taking different parameters and they're providing different kinds of aggregations in each of the parameters, so that the resulting query can be hundreds of stages long. That can take tens of minutes or even hours. But the specific part about these queries are they are always generated with the same rules. That means they're always operating on the same set of data. Let's say when user A is querying for some of his information, it will always return the same fields of information regarding this user. And when user B are going to the same UI, he will also get the same fields for his information. So these are operating through the same set of data, and this can always be helped by the data caching solution. So with those use cases, we summarize that we have our majority of daily traffic are always reading data from the last several days or a limited time range that is a moving window along the timeline. And it is only from a limited number of data sets. One of the major bottlenecks that we discovered during our execution is the read speed from S3 is slow, and sometimes it can be unstable. Let's say when we're reading from the ADFS, it can read by up to 1 gigabyte per second. But if we read directly from S3, it is bound by net bandwidth, and the speed is also bound by the threads that are reading from S3, which can be as low as say tens of megabytes per second, which is very slow for big data computation. So that's why we're thinking about caching solution, so that we could cache the data inside our VPC, or even inside the same computational node that Presto is running on, so that we can escape all those bottlenecks incurred by S3. And for the most commonly used data set, we could not only reduce the amount of data we read directly from S3, but also increase the reusability of our resource. So that's why we're looking for a caching solution, which must be able to integrate with our Presto and HighMath style and able to cache the input data based on the query. So it must be on demand. It cannot do some, we cannot just define some pre-caching and let them do it, because we cannot manage all the user queries that are running. We want the caching to be dynamic based on the user query and based on the user demand. And it should be able to flush based on the frequency of data access. So the least frequently accessed data should be flushed out to make a better performing deployment. And it must be scalable because we are working on the scalability solution to improve the performance, and big computation performance is highly impacted by the scalability of the framework. So with all those prerequisites, that's why we come to the solution of Alluxio that we say meets most of the standards that we're requiring. It has inherent integration with Presto system. It also provides a wrapper around the high meta store so that we could use its own catalog to perform a seamlessly migration process. And now we come to our Alluxio hub, and let Yichuan talk about this.
So in the next few slides, I'm going to talk about how we set up Alluxio to help our computational needs. So this is our Alluxio setup. So previously, we only have Presto coordinator, Presto worker, Hive metastore, and S3. So the original, the old way of people querying data is there's user send a data request. Presto coordinator will talk to Hive metastore to fetch the metadata, and then assign tasks to Presto workers, which will later fetch the actual data from S3. And now with Alluxio installed in place, now the query data flow becomes user queries the data through user send a data query request through Presto coordinator. It will talk to Alluxio master to fetch the metadata instead of directly talking to Hive metastore. And then it will assign the tasks to Presto workers, which will later again talk to Alluxio master to fetch the data. And on the Alluxio side, it internally, Alluxio master internally in the background continuously keep in sync with the Hive metastore to keep fetching the latest metadata we have. And then after the Presto worker send the data request, it will first check with Alluxio worker, see if the data requested is already in Alluxio worker file system. If it's not, it will read the data through S3 and cache the data into Alluxio file system and then send the data back to Presto. So this is how it works with Alluxio setup. Next slide. Okay, so there are two ways of setting up Alluxio. One is standalone Alluxio cluster, which means we create bare metal machines for Alluxio master and Alluxio workers. Also, there's another way of setting up an Alluxio system with Presto. It's co-located. So we can have a standalone Alluxio master with Alluxio workers running alongside with the Presto worker machines. So here are a list of comparisons between the co-located method versus the standalone method. So the pros of co-located method, it has lower cost because we don't need to create new machines for Alluxio workers. It has better utilization of virtual machine resources because Presto workers are mainly using CPU and memory resources. It's not using the hard disk resource. And we can put the Alluxio workers into the Presto worker machine and set Alluxio to only use the SSD resource so that it doesn't compete resource with the Presto worker. And it can reach the same good effect for cache solution. Third pros is it can skip the hop between different VPCs. So it doesn't need to be like Presto requesting data in a network transfer from the standalone Alluxio cluster. But there are also cons of co-located. First is since Presto cluster can be auto-scaled down whenever there are less queries. So the auto-scaling and graceful shutdown of Presto workers will also affect the Alluxio workers because it's in the same machine. Secondly, it might impact the bandwidth with Presto workers. Also, the Alluxio workers will also consume a little CPU usage, a little CPU resources, which might affect the performance of Presto as well. Then for standalone cluster, the advantage of standalone Alluxio master is, according to the previous one, it won't be affected by the Presto cluster changes. So if Presto got auto-scaled down or up, the Alluxio file system won't be affected. Also, the Alluxio system can be extended to other usages, not only to Presto, but also can be used by Spark, Flink, and etc. The costs are also very obvious. We need to create more machines, which means more cost. And also, there will be network transfer. Even if we configure Alluxio to use memory to cache the data, it still cannot avoid network transfer. So network transfer versus if there's co-located machine, then it's going to be data locality. And according to the Alluxio doc, data locality is still better than the network transfer. Next slide. So here are some stats based on our performance tests. If the data is warm, which means the data is cached already in the Alluxio cluster, then we do see a 30 to 50% of raise in Presto read. There are two perspectives here. So one is it does increase the read throughput a lot, which can mean like hundreds of megabytes per second of read throughput increase. And also it reduced the total numbers of rows to be scanned. It can reduce the number of rows from billions to millions. It's a huge improvement. And we do see a overall of around 30% of improvement over our data intensive queries on Presto. And also it eliminated the potential issues caused by the the connectivity to S3. So sometimes reading from S3 might lose connection or retry or something, but reading from from local machines doesn't have that. We do meet some technical challenges during the process of setting up Alluxio. First one is when trying to read the code data from S3, the Presto cluster with Alluxio performs a little slower than Presto without Alluxio. This happens during our POC stage that we have a small Presto cluster with Alluxio. The reason might be that Alluxio first needs to load the data from S3 to its own file system and then dispense the data to Presto. But once we move to a bigger cluster, that issue is gone. Second problem is we have some huge Hive tables with over 40K of number of partitions. And Hive itself have this problem reading a huge amount of partitions. And we actually communicated this problem with the Alluxio team, and they had a solution handy very fast to help us resolve that problem. And now it's working. Third problem is handling large tables. So we do see there will be a gRPC issue if the table is too large. Also the Alluxio team gave us suggestions to change the way of transferring data to streaming. And then that helps us resolve the problem as well. So yeah, that's all the presentation we have.
Yeah, that's all from our side. So based on our experience with our existing Presto and Alluxio cluster, it really brings a lot of improvements, and we're trying to roll it out to our other Presto clusters to improve our performance. Thank you a lot. And feel free to let us know if there are any other question you want to ask. Thank you.